So if you're just starting out and you're writing some Ruby code and you want to learn some object-oriented basics, one of the best ways that you can do that is to build some games. So in a previous episode, we talked about building Hangman, which is a pretty simple game. We looked at both the way that you might write it just sort of by calling functions and passing some data around with local variables. And then we built it into a single Hangman class where you could just call methods on the instance of the Hangman class, and those would result in playing the actual game. And so what I wanted to do now was really step it up, not one notch, but 2 or 3 notches here, and walk through the process of building out chess. So this is going to be a series of videos, and if you follow along, then you'll be able to, at the end, build a very simple chess game. We're not going to, probably won't implement things like en passant or like crazy, like intense chess moves, but the goal is that we'll be able to build out a very simple chess game with pieces that we can move around a board, and we'll have 2 players and some really basic logic for checking if the game is over or not. I'm not a huge chess player. I know some basic rules of the game, but I do think that this is a really effective way to learn object-oriented programming. And so in this first section, what I think it makes most sense to do is just talk about how we organize our code in a project like this. And so I'm looking at Replit right now, and I do want to build it on Replit so that you can sort of take this resulting code and go play with it yourself and experience it yourself. All right, so the very first thing that I usually do is add a lib directory. And in the lib directory, this is kind of the library where all of our code is going to live. And then we want to create 1 file per class. So a class in object-oriented programming is a type. It is going to be sort of the prototype or the blueprint for instances of that type. So you can sort of think of this as blueprints for the types that you're going to create. This is going to be the list of the methods that are available. And this is also where we sort of define how the logic works for each sort of instance of those classes. So let's dig into it here. So the very first thing I want to make is probably a board class. So I'm going to call board.rb here. And in our board class, we're going to start it with class and board. And the name of our classes are always going to be capitalized. That is a special thing in Ruby, and we're going to start with class and just an end at the bottom. Now, in between the class where we define the name and the end, this is where we're going to write all of our instance methods, class methods, and where we're going to actually write the logic for what the board is responsible for. And so one way that folks often learn object-oriented programming is to think about the nouns in their system as the classes, and then you think about like the verbs as the methods, or like the actions that are happening between those classes. That's sort of like classical object-oriented programming. Now, one book that I highly recommend is called Pooter. It's like Practical Object-Oriented Ruby, Practical Object-Oriented Design in Ruby. This is written by Sandy Metz. Very, very good book. Really well written and has some really, really strong object-oriented principles and design methodologies that are really valuable. So I definitely recommend checking out this book, Pooter, by Sandy Metz. And what she does is she sort of flips it on its head and says, first think about the messages that you're going to be sending between the actors in your system, messages. And this is really sort of like the methods that you're calling. And then you have like the secondary thing is like the actors, or this is going to end up being your classes. But you don't have to really think about the classes until first you think about how the messages or which messages are most important in your system. So these are kind of 2 different ways of approaching it. I learned the first way, where you kind of like think of all the different nouns in your system and then create classes around those. Both are totally valid. The one thing that you want to keep in mind is that a class very often should be responsible for one thing, the single responsibility. So this is a board class, and its pure responsibility is going to be managing the board. So we're going to try our best to keep it just to managing the board. And in practice, you might even create like special classes that are specific to rendering the board. Initially, we're just going to assume that some other class is going to actually render out the board. But what do we want the board to look like? So I think this should actually be stored as sort of like a 2D array, where the the rows are going to be the index into the array, and then the columns will be some position in a subarray. So we're going to have sort of like arrays of arrays, right? Where like the top level array will give us like the rows, and then the subarrays will give us columns. And then at each point we can have like a piece, either a piece or a nil. And so we'll have sort of an 8x8, 2x2, or I'm sorry, we'll have an 8x8 2D array that is the internal representation of the board. So here, let's say def initialize. And we're going to say like the internal representation, we'll call it the grid, just to keep it, just to keep things separate. Now, what we really want to do here is initialize this with a 2D array. And we can do it a couple different ways. Like, first of all, what we could do is have a method that like sets up the whole board and actually like creates the pieces and puts them on the right places on the board. Or we could inject the grid into the board when the board is initialized. But I think what we might want to do is to start, let's just put in like x, nil, and x. And what we're going to try to do is sort of get something working so that we can just see what this looks like on the board. We don't even have like the right dimensions yet. We'll just make it 4x4 to start, and then we'll start playing around. Now, what are some things that we might need to do on the board or with the board, right? So a couple of things that come to mind. We're going to want to like place pieces, and we're going to want to like have a way to check to see if we're out of bounds. We're going to want to probably have methods for getting or retrieving a piece at a specific position. So like get a piece, and then there's likely other things, but let's start with that. So if we wanted to place a piece, one thing that we might do is write a method that's called like place, and then it takes in a piece, and maybe it also takes in a location, where the location is going to be like some pair of x, y. So we might expect that this place method takes in the piece object as the first argument, and then an x, and then a y, or maybe like even like row and column or something, right? And then we can find that row and column in our grid. So I put an @ sign at the front of this name here, grid. I put the @ sign because this is going to be an instance variable, meaning that every time we create a new board, each board should have its own internal representation. We don't want the boards to all share the same internal representation. So for instance, if I say like b equals board.new, b.place, and then I give it a piece, king, and then it's going to go to like 1, 2 as the position. And if I have a separate board, right? So imagine that like I'm sitting at a dinner table, and on one side of the table, I have board that's B, and then on another side of the table, I have like B2 is board.new and B.place, the king on 0, 0. These are actually going to be two different boards. So I'm sitting at the dinner table, I have two different boards, right? And their internal representation of the pieces on the board, B, so this B1, right, or B, has a king at position 1, 2, and then B2 that's over here is going to have a king at position 0, 0. And because I'm using the @ sign, when we call this, or when we're working with our board objects, they will have this grid instance variable is going to be an internal representation of the board, of like where the data is stored for that board. All right, so we've got this place method. Maybe it takes a piece, maybe it takes a row and column, and then perhaps it's going to say like @grid, @row, and @column, and then that's going to actually set that equal to the piece, right? So this is an example of how we might write a place method. So let's do a little bit of refactoring. The very first thing I want to do is, other than the initialize method, I want to try to sort of avoid using the instance variable directly. Instead, what I want to do is use the bare word version of the instance variable. And in this case, what we can do is we can use attr reader and give it a grid. And this will create a method. So by using attr reader here, we're actually defining a new method, grid, that just returns the instance variable grid. So these two lines are like this line here, line 2, and then lines 4 through 6, those are functionally equivalent. They're the same thing. They do exactly the same thing. This one is just a shortcut. It's just a sort of, it's called syntactic sugar. It makes it easier to read. And this is such a common thing that we're going to do that this makes it easier. So the first refactoring that we want to do is we want to avoid using this, the instance variable directly, and instead we want to use grid. And the reason is that if later on we decided that every time we access the grid, we actually want to do something else, or if every time we access the grid, we want to make an API call, or we want to send an email or something like that, then our def grid method, we can still return at grid at the bottom, but first we could do something here, do something, right? And then we have just, and then we could just comment this out, right? Like if later on we wanted to like do something every time the grid method was called, then we could do that here, do something, right? And by making that small refactor where we just remove the adder reader and we add a new getter that still returns the instance variable, but it also does something, it makes that type of refactor very easy. And so that is one of the reasons why we want to use what's called the bare word instead of using the instance variable when we're working with our classes here. So I'm going to comment that back in. All right, so we've got this grid. So every time we call the grid method, we're sending the grid message to ourselves, and we're getting back this 2D array, which is the internal representation. And then we're reaching into its row, which is going to be like picking which of these arrays to use, and then the column, which is which element in the array. And then we're going to set that equal to the piece. So a couple of things. Number one, rather than passing around row and column, because we're going to be working with this locations on a grid very frequently, or locations on the board very frequently within the game of chess, right? We're going to have like positions where a piece can move, right? Like a knight and a rook have like certain directions they can move, and certain pieces that are able to move in different directions. Those directions will also be defined as these sort of pairs of X and Y, which allow you to move forward or move backward or move side to side. And so because the pairing of the row and column, or the pairing of the X and Y, is so common, instead of passing those as separate arguments, it is a better practice to pass them as a single thing, a single argument. So we can just say location here. And instead of passing in row and column to the method, we can extract the row and column from the location using array destructuring like this, row, comma, column is equal to location. And that will just automatically sort of destructure the array. So if we receive a piece, if we receive a message, that place message with a location, so now this is going to look a little differently. Now we're going to have b equals board.new, b.place, like king somewhere, and then instead of passing 1 and 2, we're going to pass them as an array, 1, 2. Now in practice, we might actually even create a location class that is like purely responsible for validating that a location is legit, and like you can't have negative locations and you can't have whatever. But for now, we're going to keep it really simple, and every location will just be passed around as a single element, or I'm sorry, a single array with 2 elements. So that's what our sort of location will look like. Now, if you've worked with arrays before, and I'm hoping that's sort of like a prereq to this, but if we have an array A and it looks like this and has 1, 2, 3 elements in it, and you ask yourself, how do I get the first element out of this array? Well, you might say like puts A at square brackets 0, right? Or alternatively, you might say puts A dot first. But what I wanted to talk about was this square bracket thing that we've seen elsewhere, right? So in this case, A itself is an array. But when we are looking at the first index here, this square bracket, when the square bracket is right next to A, this is actually calling a method on A. And the method is a special kind of method, and that method is the square bracket operator. So this is a special kind of operator. The same way that like you might have like 1 plus 2, this is actually a method. The plus method here is a method. So A at 0 is a method. So let's try running. Let's actually move this into main here so we can run that and just take a look at what it does. So I'm gonna run this, and we will see that if we puts out 0, we should see 1 print to the console, and we do. So what's interesting is you can actually, I think you can put a dot here because it is like calling a method, and the method is the square bracket operator. Okay, let's see. Maybe I need to call it like this. Okay, look at that. All right, so we get back 1. We still get back 1. What's so interesting here is that this dot square brackets is the method, and this method is the getter method. It's the method that is like extracting something from our 2D array. All right, now this is where it's going to get even more interesting, is that if we say puts A down here, we can actually use the setter method, right? So typically, if we wanted to change the value at index 1, let's say we want to set the value at index 1 to just like test, right? And then we're going to put out A, and it's going to say 1, test 3. That's what we expect. So this here is, okay, so now we see 1, test 3. It's not printing it in array status because we're using puts, so it's making it pretty, but this is also a method. So the square bracket operator, we pass it the index of the thing we want to set, and then we have this equal sign on the right side. This is another method that is available on array. So it turns out that we should be able to also call a dot square brackets equals, and then call this with 2 arguments. The first is going to be the element we want to change. So let's actually change 3 to test now. So it says 1, 2 test, right? So this is the index into the array, and then this is the argument that we want to set the value for. So here we're calling the method, and we're calling it with parentheses because we want to set the value. I'm sorry, it doesn't matter. The parentheses part doesn't matter. The set value is because we're calling the square bracket equals operator instead of the square bracket operator. And we're able to pass it these 2 arguments, and that ends up setting it. So why does any of this matter? What's the deal? Well, it turns out that like when we're defining our own classes, we can do what's called operator overloading. So we can change what it means to both retrieve and set values on our custom board class. So let's do that because I think that's pretty cool. So here, instead of our place method, let's make this the square bracket equals method. And then we want to actually swap the order of these so that the location comes first and the piece comes second. Now, when we go to call this method, we're going to call it by passing in first the location. So we're actually going to use the square bracket operator. We're going to say location and then equals king, or whatever our piece is going to be. So then the location is going to be like, 1, 2. And now we can use this setter method just like this to set the value at that location. Let's just pass in like y for now, and then we can print out b dot grid. We'll just make it like print out the whole grid so that we can take a look at this. So let's actually move this up to main, and we will require relative ./lib/board.rb. We're going to initialize a new instance of the board. We're going to create a location and use that setter method to take this value and put it onto the location at 1, 2. Actually, let's use 0, 0 so it's a little bit easier to see where it came out. And now we see that in location 0, 0, we have a y instead of an x, okay? So this is the setter method. I think this is pretty cool. So this is the setter method. So again, similarly, we can use this for get. So we'll just copy this and paste it down here. And the difference between get and set is with get, we only need to take in the location. We don't actually need to pass a piece. And then we're just going to return the value at that location. So now if we go back to our main class here, if we were to say like print out b at location, then we should expect that this prints out y, right? So we will run that and we get back y. Super cool. So I've kind of done something a little fun here because I've created this loc for the location, this local variable that has our 2D array. But if we were to like actually do this with an inline sort of like array that we're just defining here, we might say like b at like what is the value at b location 1, 1. And this is super weird to kind of look at because it has 2 sets of square brackets around it, but this is actually valid also. So we can print out what do we see at location 1, 1, and we actually see X. And I think that's also expected. So we could just say like pb.grid, and that should give us a better look here. So at location 1, 1, we're looking at the first array's first element here. So that's 1, 1. If we did 1, 2, I think that should give us nil. So let's take a look. And we got nil back. That's great. So this is kind of a couple of convenient methods that we have on board. Now let's make another method here called out of bounds. And this will also take in a location. And what we're going to do is, again, destructure into row and column. And we're going to check, is the row less than grid.length? And is the column less than grid.first.length? And I think that should be like pretty close. We actually also want to check to make sure that, that they're greater than 0. So we can do that. So row is greater than or equal to 0, and column is greater than or equal to 0. So this should tell us whether or not a location is out of bounds based on what our current internal representation is. What's neat about this board class so far also is that it's 4x4, which isn't a technical like chess grid, but it should still like work in pretty generic ways, right? Like we could reuse this board if we wanted to with a tic-tac-toe board, or we could reuse it for checkers or chess or a couple other like grid-based boards, and that should totally work as expected. And then here what we might do is say like we'll print out a couple things. So we'll just say like b dot out of bounds. Is it out of bounds to go to like -1, 0? That should be true. Or maybe we should call it inbounds. Inbounds, right? Because we said less than, greater than. Yeah, so this is inbounds. So if it's inbounds, and then let's give it a valid one. So 0, 0. Let's also give it like 1, 1. And then we'll go over and above. So in our case, like our temporary one is just a 4x4, so that should fail. So we should have, yep, it's not in bounds, it is in bounds, it is in bounds, and it's not in bounds. So that works. That's totally cool. And so now we have a board class that has a couple of methods on it that I think should be really helpful. So I'm going to wrap this episode right here. We talked about how to create a class and how to put it in the right file. We talked about these instance variables and why we want to initialize and set the instance variables inside of the initialize method. But then later on, we only want to use the bare word to access them. We talked about operator overloading and passing in locations as the pair or the tuple of the X and Y. And we built a couple different methods here. This one in particular, I like having the question mark at the end. That's sort of a convention when you're returning a Boolean value. So again, here at the end, this is sort of like a multi-line expression where we're putting the ampersands at the end. So we're evaluating each of these in order, and then returning the whole result of this entire thing, which tells us whether or not we're in bounds. Yeah, and we talked about how you generally start thinking about these object-oriented systems with nouns and verbs versus messages and methods. So hopefully this was useful. If it was, I'd really appreciate a quick like. And in the next video, we'll talk about some other part of the chess system and we'll continue building this up. Thanks so much for watching. We'll see you in the next one.